And the slide says feature presentation, but we are actually ready for our lightning talk.
Right. It's great to meet you all. My name is Matthew Hess. I live in Albuquerque, New Mexico, and I'm joining you this evening from a hotel in Vancouver. So I was able to give a full talk to the group here. It was really exciting. And I'm going to talk to Joe and I were kind of kicking around what would make a good lightning talk. And we kind of thought that, just kind of going over some of the cool new-ish language features in C Sharp. They're always putting new stuff in, and sometimes it's a little hard to keep up with all the good new hotness in C Sharp. So this evening, I picked out one of my favorites, pattern matching switch expressions, which are relatively new and very cool. And if you haven't used them, you'll be excited to learn about them. And if you like what you see and you think I'm funny, or you just want to connect, you can connect with me on LinkedIn. You can take a quick snapshot of that, or you can connect with me on YouTube. I've got a YouTube channel, the C Artisan, ton of videos there that you might be interested in. So we're going to talk about pattern matching switch expressions. So with that little intro, let's get going. It's all going to be here in Visual Studio. And so I think probably everybody knows how to write an if-then statement. Here's a little simple if-then statement where you pass in an integer and you get a string. If input is 1, return lemon. Else if input is 2, return orange. Else if input is 3, return grape. Else return unknown. So this is the kind of original branching statement that you would get, and it's a little clunky, but it works, and it's very readable. So C Sharp also has kind of the original or classic switch statement, and it's a statement, not an expression. So the difference between a statement and an expression in C Sharp is that statements don't return values, right? They kind of return void. They perform actions, whereas expressions return values. So technically, this is your switch statement. And you can express the same concept. Switch input, case 1, return lemon, case 2, return orange, case 3, return grape, default, return unknown. So it might be a little bit better, and we could take out some white space and hard returns, but honestly, these two, they're pretty much equivalent in my mind, and I have just always tended to avoid switch. But now let's look at the new switch expression. These are pattern matching expressions. And so this first one would be called a constant pattern, which means you are matching against some constants. So the left side of these arrow functions, or these arrow expressions here, is a constant. So here's how we can implement that same concept. Give me a string based on the integer input using pattern matching switch. So we simply return input switch, and then 1 gives you lemon, 2 yields orange, 3 yields grape. And this syntax here, this underscore, is called the discard, and that's kind of the equivalent of your default or your else, and it returns unknown. So that's kind of the simple basic example, and as kind of a thumbnail, with or a way to remember, switch input, the keyword goes first, but with the new one, it's input switch. The switch comes after, and it doesn't get enclosed in parentheses. So if you don't get anything else from this lightning talk and you just remember that this syntax exists, you've learned something. Now you can make this even a little more concise by implementing the function like as an arrow function. So here we go, public static string, same concept as an arrow function, where we simply return input switch, right? And there's no return statement at all. It's just this expression here that yields out the value that you need. So that's very cool right there. That's super, super concise bit of code. So there are other patterns, and I'm going to go over kind of the important ones that I think, well, the ones that are fairly common that I would be using. There are some esoteric ones, which I probably won't go into. So there are relational and logical patterns, and this combines both of them. So a relational pattern is like this, where your the value that you're switching it has some relation, some relational expression like less than 0. Here's a constant one, equals 0. Here's a relational one, and then you get logical. So if it's less than 0, we get negative. If it's 0, we get 0. If it's greater than 0 and less than 10, this will return the words single digit. And if it's 11, 13, 17, or 19, it returns the words two-digit prime. And the discard is some other number. So this is kind of cool because you get these Boolean, these Boolean logical operators in here, these keywords. And what's nice is you can use the plain English keyword like and or instead of mucking about with ampersands and pipes, which, again, for those of you who grew up on C++, it's natural and you love it. But for everyone else, it's, do I use 1? Do I use 2? It's a little bit error prone and confusing. And honestly, it's just kind of nice to use something like English that's literate. So I love this kind of way of expressing the logical operations. So that's relational and logical patterns. The next one is using an enumeration as the constant. So this is really the constant pattern, but with an enum. And I use this a lot. So let's just say you have an enumeration here, our breed enum, Shepherd, Retriever, Chihuahua, and Heeler. So we pass in a breed, we return breed, switch, and just some strings. Shepherd's very smart, Retriever's very gentle, Chihuahua's very yappy, the Heeler's very energetic, and then our discard is, in this case, throwing an exception, invalid breed. And that seems legitimate to me because this is the one where I'm kind of like have a question, because why does it even require a discard? Can't the C# compiler figure out that there are only 4 possible breeds and therefore this is complete? But it doesn't. And if you don't include the discard, it squawks and it says you're not covering every case. So you do have to include that even with using an enumeration. And maybe somebody at Microsoft will watch this video and be like, oh, yeah, no, actually, that's true. We could fix that. Or maybe there's some reason I don't understand why it has to be that way. So there is using an enumeration. And here is kind of an example of applying a switch expression as kind of a factory method. In other words, our function is returning a class. So I've built a little kind of data class here, which has intelligence, aggression, noise, and energy. I do want to point out, since this is about learning some tips and tricks with C#, you may not know, but in addition to get and set on your properties, you have init, which allows you to set a value in the initializer like this, but then it becomes read-only thereafter. So this is a really cool way to get a little bit of kind of object-oriented protection for your data, not having to make everything read-write. You can make it get and init. So here what you can see is we're switching on the breed as a constant on the left side, but then on the right side, we're calling a constructor to make a breed profile and we're returning it. And we're saying that our Shepherd profile is really smart, moderately aggressive, very quiet, and mildly energetic, whereas our Chihuahua is not the brightest dog in the pack, pretty dang aggressive, extremely noisy, and very energetic. I have a Chihuahua. If somebody would like to adopt him, after this, that's just fine. So this is kind of a example of the factory method approach. And then in this case, it's natural to return null, because if you've passed in a bad breed, you don't actually create an object. So returning null is okay there. And the last, I think we're getting towards the last, it is possible to switch on an object and then use the properties of the switch object on both the left and the right side of the arrow in interesting ways. So we've got this dog class where we have a breed, a name, and an age. And so you can do something cool where you can say, okay, basically, look at the age property of the dog. And if it's less than 1, we can return this string. The dog, using the name, is a puppy. Now here's another one of my favorite newer kind of C# language features is string interpolation. If you are still doing string.format, you need to look up string interpolation and learn this syntax. It is so powerful and elegant, and people who work in languages that don't have it get jealous when you show it to them. So this is really lovely. String interpolation and you can see we're using the name property on the right side and the age property on the left side of the arrow in our switch expression. So if it's between 1 and 3, it's a young dog. If it's greater, between 3 and 8, it's an adult dog. If it's between 8 and 14, it's a senior dog, and anything over that we're going to just call a miracle. So the last thing I want to show you, that the problem or a challenge with the switch expression is because it has to return a value, it's a little awkward to kind of use it as a function dispatcher, right? That with an if or a switch, you can easily say if some value, then call the function, semicolon. Else if some other value, call the function, semicolon. It works really well. That's what it's made for, is basically branching your code and calling functions. So there are a couple ways you can still use the switch expression to do that. You just have to have functions that return a value. So you could say, all right, all of these functions return a Boolean or return an integer, like a return code. That's fine. That's a perfectly legitimate style. What I have found is kind of neat, though, is to create a collection of functions that are all marked as async. And so they return tasks because async functions return a task. And so now I've basically got 3 here. Just a moment, delays, writes out this to the console and delays for half a second. Give me a sec, delays for a second, and hold your horses, delays for 2 seconds. And so now I can write a function called choose what to do, where I pass in an integer, an input. And if I get 1, I'll call just a moment. But actually what I'm doing is I'm returning a task. So we're saying task T is either the just a moment task, the give me a sec task, the hold your horses task, or you didn't give me a valid thing. And then I can await whichever task was instantiated. So here it is kind of hijacking the pattern matching switch expression to create a function dispatcher. So this all compiles and runs. I've got a little test app here. I'll just run it. And Joe had actually talked about having me come back and do a few of these. So once I collect them all, I'll put this code up on GitHub. I don't have it on my GitHub yet, but I will get it up there soon. So it's just a demo, and it just runs through some examples. You saw it run there, but if you look at the program, you can see what it does. Like it calls constant with the number 2, as arrow function with the number 3, relations and logical with the number 17, on down. And again, I can just run it, and you sort of get the idea of each one of those being exercised. So there you go. There is your lightning talk to kick things off, pattern matching switch expressions. Again, this is a little about me if you want to connect, and I'm really looking forward to tonight's talk. So thanks everyone for your time.
Thank you, Matthew. Any questions or comments for Matthew before we move on to our featured presentation? No, doesn't look like it. All right. Well, thank you again, Matthew. Appreciate it. Yakin, you are up. I will make you presenter.
Okay. Great. I think there was a comment about the presentation from Matthew that it seems similar to dictionaries now that you use the switch expressions. Maybe have a look in the chat and Matthew might comment on that.
I agree. I feel like that the inspiration for this style of programming, the reason they've brought it in is because of Python and because of functional programming languages that are very data centric. And I think you're exactly right that many of us attempted to achieve that sort of data-driven or data-centric functional programming style in C# using dictionaries. I don't know if I would say it replaces dictionaries. A dictionary is a highly optimized data structure because things are hashed and the lookups, it has this functionality to it, which If you just are hand unrolling that dictionary into code, it's, you lose something. So I guess I wouldn't say it replaces it, but it does something kind of similar. And you could combine the techniques. In other words, you could, I think, well, I'd have to think about that, but it's a really good thought. I think that's, you're on the right track there. And there are other patterns you can look at too. So those of you out there who might have done some Python may be going, oh, I know exactly how to use this, right? And you can maybe share some examples with the group later of like, here's a real world situation where I used it. For me, I tend to use it in these very simple ways, just to clean up my ugly, grungy if then and case statements that can be written more elegantly. So great comment. Thank you. And thanks for noticing that, Jochen.
Yep, my pleasure.